This is a bit of a Maximum PowerPoint charge controller addendum video on top of the addendum video for my really old charge controller recommendations video. As far as some oddball but possibly useful niche applications for Maximum PowerPoint charge controller, one of which is something like a multi-channel Maximum PowerPoint charge controller, which at this point for off-grid systems does not exist to my knowledge, where you have one charge controller that can handle the inputs from multiple photovoltaic arrays. There are grid tie inverters that do have multiple Maximum PowerPoint charge controller channels, but the ones that I know of that do that, at least on the not bloody huge scale, only have two on in the low thousands on watt sizes. Now this would be useful in various niche applications, like for example for an off-grid type system where you can only afford to buy a few hundred watts of modules at a time, and because Maximum PowerPoint charge controllers work best with matched modules, ideally identical model number, type, cell type, ideally even same production run, and also same date of install because they do degrade with age. And something where this is where you have a certain number of Maximum PowerPoint charge controller channels, and you can just, with one charge controller, add, say, a few hundred watts here, a few hundred watts there, and just bring those different arrays into additional channels on the charge controller. Now, something like this means that the controller is a single failure point, but at least with my design, I'm working on having a card cage system where each potential converter for each channel is on its own card, the controller is on its own card, dump load management is on its own card, so one of those dies you can easily pull it, which is, one of those things about ease of maintenance, but then again, my design isn't for absolute minimum cost. And another thing that would be interesting, and there is a company called Pika Energy that is developing something like this, but despite the fact that they mention a lot of things about it being a fairly open thing, they don't have anything as far as the power line communications or what have you that they mention for how each Maximum PowerPoint tracker for each photovoltaic array, even though in a lot of their stuff they only mention one of those and one wind generator combined with either one GTI or one battery charger, what exactly the protocol is, although obviously be some kind of a single wire serial. I'd imagine probably a DC equivalent of something like X10, although it obviously wouldn't be X10 because that relies on zero crossing points for synchronization purposes. But one main thing with that is because it uses 300 is with the Pika Energy system is because it uses 380 volts. Dealing with that is a lot more complicated, not necessarily with the wiring, because 600 volt stuff is quite common, but fuses, because fuses that can handle that, especially fuses that aren't obscenely expensive, that can handle clearing arc faults on 380 volts, are not all that common. Whereas something like this that operated in the 150 volt or less range, just because there's a lot of various regulatory hurdles that are at least lessened for things under 150 volts, so 150 volts DC is one of those kind of stepping points. And also, the Pika Energy Maximum PowerPoint tracker is rated at a nominal maximum power rating of about 2 kilowatts. So, whereas something like this, where you have a single charge controller, say 150 volt bus linking various Maximum PowerPoint trackers and their respective photovoltaic arrays, because you can just have one cable run and then just goes to one array, then another array, then another array, versus one array versus one home run for each array, which would of course get kind of expensive. Now, of course, the problem here would be single point of failure again, but that's why things like having scaled charge controllers, where you have one potential converter that's standard that can handle a few hundred watts, and you just have multiple ones of those. And if your control system is implemented intelligently, it'll stagger them, where it'll bring one online, then when, say, another array gets exposed, like say at midday, when this array starts getting sun, then it'll bring an extra charge controller online, and then when the first array gets shaded, it'll shut off the first charge controller, but leave the second one on as a bit of a wear leveling measure. But that's just basic proper design of things. And of course that thing would also handle dump loads, especially with wind, because you don't want the wind turbine freewheeling, because otherwise you can overspeed, shed bits, you know, chunk of fiberglass going through your head is kind of injurious to the health. But anyways, I also don't know if there's any kind of strange patenting on this where you have for there's a separate patent for an individual maximum power point tracker at each module or each array, and then a common charger. Although I know that there are chips that are available that do things like that. Things like an SPV1020. It's a ST microelectronics device that's intended for use in a... They're actually intended for use where you integrate one of these into the junction box of each photovoltaic module. Of course, the thing about these is that they seem to be intended for things where you have a number of these wired in series. That's also why there's an anti-parallel Schottky diode across the output, so where you have current flowing into this node and then out of this node. When this array isn't getting any sun, that means that it just bypasses all of that, and basically all this sees is just the potential drop across the array, or across the diode, which, it being Schottky, would only be on the order of a few hundred millivolts, or even less if some special devices intended specifically for photovoltaic bypass diodes, where they basically are just a FET, so that you get potential drops in the low tens of millivolts range, because you're dealing with a fairly low on-resistance FET. And of course, when it comes to DIY maximum power point charge controllers, there are devices like the Solar Magic 72000 series by Texas Instruments, although they're originally developed by National Semiconductor, which would be quite interesting from a DIY maximum power point charge controller standpoint, except for the fact that these are in various hard to work with, nasty surface mount packages. Not necessarily hard to work with if you have proper, even things like just a hot reflow plate or reflow oven, which can be jerry-rigged. But the issue here is repairability, because soldering these, especially some like this device in the part series, the SM72295, that's an SO28, which isn't too bad. Those are 50 mil pin pitch devices. But repairing is a bit of an issue, especially because it's surface mount, especially depending on the solder alloy used. It's quite easy to lift tracks, especially if you're making your own boards. Because I've done that in some of the repair work that I've done on some of my prototypes for my maximum power point charge controller project. So it'd be quite useful. So any of you TI guys who are listening to this, especially if you could make the 72295 in a 28-pin DIL, which is standard package. Likewise, the SM72444X series, like this is SM72442. This is just the schematic for a dev board that they have for these chips. Problem is the dev board's $150. And those are the two main chips in the series. It's basically just the maximum power point charge controller chip that does all the calculating, although there is an external microcontroller, but just a bog standard PIC that does all the actual charge threshold and mode selection. And this device, which isn't essential, but it's for FET drivers and some current sense amplifier / buffers for the current sensing shunts and various other useful features. So it's basically a one chip that replaces a whole bunch of things, because everything else in all the other various Solar Magic parts, they could all be replicated with other things. Although some chips like the SM72485, which is just a 100 volt input maximum think brain power supply buck converter chip, basically something in the lines of the MC34063, or something like the a Maxim MAX5033, which is a device that I have under consideration for 48 volt versions of my charge controller design. Only problem is that they're more than 10 times the price of the MC34063, which is only about $3 for a tube of tin from Jamco. And of course, also because it's Maxim, there are the various supply chain issues associated with Maxim parts, which would be a concern to a small production run thing. But then again, that's something that has to be taken into account with any Maxim design. So yeah, but because everything else is just these temperature protection, which could just be implemented with just, you know, thermistors and comparators. Current limiting, that's just an operational amplifier. You know, the reset device, I mean, those are quite common. One startup device can use straight transistor. But yeah, it'd be quite useful for especially with a kit based off of this. And just for those of you for where that doesn't make a whole lot of sense, it's basically just an H-bridge-like configuration that can function as either a buck converter or a boost converter, and has the advantage over a quote-unquote proper buck boost topology in that it is non-inverting. Where basically all it does is it has, of course, the top of the H is not connected. The bottom is, because that's the DC neutral. And what would ordinarily be the load position in the H is the buck boost inductor. And basically by switching which FETs are on, it turns it into either a buck converter or a boost converter, where this FET always being on, that is the switching FET, and that is the synchronous rectifier FET for a boost, or no, for the buck converter, and where that FET is always on, that FET is always off, that is the switching FET, and that is the synchronous rectifier for the boost converter. So yeah, it seems like quite interesting chips, but very annoying when it comes to any kind of DIY anything. And for those of you who are all gung-ho for surface mount, yes, it's very useful in production environments, but there's things where small production runs where you can't afford all the requisite equipment that you need, or for things where things need to be repaired, because the main thing with a lot of the off-grid stuff that has been the subject of a lot of my previous videos is repairability by the user.